of some sort. So that would be things like petroleum processing, food, pharmaceutical products, producing materials for the electronics industry, producing different types of polymer materials, plastics, metals. So there's a wide variety. They also work in areas like environmental work, cleaning up environmental contamination, preventing contamination, air pollution, water pollution, and so on. There's a lot of overlap among the different areas of engineering. So chemical engineers do work that involves chemistry in most cases, but there are things that they apply that are not really chemistry per se. That's why they need to understand things like heat transfer, mass transfer, fluid mechanics, how fluids flow, a bit of electrical phenomena. Depending on the particular area of application, it could not, there are some cases where there's very little chemistry involved. So they're primarily doing work that involves flow of heat or even electrical work in some cases. You ask how do chemical engineers differ from chemists?
Yeah.
Well, chemical engineers study, I would say, about a third to a half as much chemistry as a chemistry major studies, so they don't have the depth of understanding in chemistry that a chemistry major typically has. But they do pick up a lot of other engineering work, such as how to operate chemical reactions on a large scale that would not typically be in a chemistry program. In addition, chemical engineers would have to think about how you transfer heat to a reaction or to a mixing process or from it, whereas a typical chemistry application might be on a much smaller scale, where that sort of thing doesn't really have to be worried about because of the geometry of it makes it very easy to remove heat. There are a lot of chemical safety issues that chemical engineers have to worry about because of the large quantities of material they typically work with. So they might be working with hazardous materials on a large enough scale that they have to provide extra equipment and extra procedures to make sure that that's all safe.
And they are doing this based on the chemistry experience they have.
Well, they would learn about the chemical hazards. Some of that they would learn in their chemistry courses, but then in chemical engineering we have particular ways of assessing hazards that they learn in some of their courses, particular techniques to go through in a systematic way and assess whether a particular situation has some risks that we are concerned about, and then there would be procedures as to how to handle those risks. So it's a matter of understanding the underlying chemistry, the underlying physics, and having a good grasp of the engineering techniques so that you could predict what kinds of things might go wrong. Other areas that chemical engineers study that chemists would not typically study would be things like process control, things like I mentioned heat transfer and mass transfer, so what we would call transport phenomena, those areas that involve the flow of how do I get heat to flow in an efficient way in a particular system, or how do I prevent heat from flowing? How do I move material from one container to another efficiently? The energy involved in those kinds of operations becomes very significant. I'd said that chemical engineers typically work on a large scale, but they actually also work on a very small scale. So they're involved in nanoscale work, certain kinds of biological processes at the cellular level. So it's quite a variety.
So is it an improving measure? So can we see like a new disciplines in chemical engineering in the future?
So can you say it again, please?
So is it like an improving measure? Like can we see?
Are you asking
Yeah.
what are the future trends? What kind of employment opportunities?
Mm-hmm.
Well, what we expect to see in the near future is a lot of emphasis on energy, for example, and that's an area where chemical engineers are going to be very heavily involved. Things like battery development, the chemistry involved there, development of the systems for fuel cells, membranes that are included in the fuel cells, the development of energy storage systems of other types, and certainly in the production of gas. There's a lot of work going on now to produce natural gas from shale deposits. There's a lot of work with producing petroleum products from more difficult situations like shale, as opposed to the easily recovered oil that you might find in some wells. So both in the recovery of those resources and then in the treating of them, because as you get things like natural gas, as you get it from nature, it might be contaminated with a lot of things that we would not want to have when we transport that into homes. So we'd have to remove compounds like sulfur compounds and some other undesirable compounds. So there's a lot of processing that goes on, drying operations, filtering, things of that sort. One other difference that I should mention between chemists and chemical engineers, because chemical engineers go through and study a lot of the engineering aspects, when they enter the workplace with a bachelor's degree, they are considered professionals. They can get their license based on having a bachelor's degree and a certain years of work. Whereas with a degree in the sciences like chemistry, you typically really would need to go on and get a graduate degree in order to be considered a professional. There's a very significant difference in starting salaries between the two as well. $25,000 difference with the engineers being on the higher end.
I think that's all.
Yeah, okay.